Tonight we're given a system of quadratic equations with a common root, and we'll call that common root just r. Okay, and we know that f at r, here's f, or g, I guess. What do I do? Okay, let's erase that. Okay, so what we have, this would be g at r. Our two equations are named g of x and h of x. So we have g at r is equal to 0 is equal to h at r. Okay. H evaluated at r. You know, again, the common roots right here would be r. Okay. So that turns out to be pretty valuable information. Okay. Now, also, something else we know about this system or each of these guys is that they each have two roots, not necessarily distinct because their degree is 2. So you can write this as x minus r. And we'll just use subscripted variables here. So we'll say x minus r sub 1. Like that. Okay, and then down here, you would have, again, it's a common root, so we'll write down x minus r. Again, for every 0, for every root, there's a corresponding factor. It's called the factor theorem in college algebra class. Okay, so you have x minus r sub 2 right here like that, right? Now again, r and r, the r's aren't necessarily distinct. They have different names, but that doesn't mean they're distinct, okay? Now that's important because when you expand this out, and again, we're considering this, each of the elements in the system to be equal to 0 because we are interested in common roots and roots in general. And so what I've done right here is just some manipulations. You divide through by the leading coefficient in both cases, get this system. And then right here, based on these assignments for our roots or our zeros, we get this statement here. Again, when you expand this out, the minus sign hangs around right here, okay? Notice we have R1, R2, and so on right below it, okay? So we get to this situation right here, and we're in a position where we can actually equate coefficients. Oh gosh, I just noticed something here, folks. This should be times x, right? Sorry. And that should be times x right there, right? I just forgot to write that down when I was doing it earlier. Okay, it should be times x. Now we're in a position to where we can equate coefficients. Notice that a over 2025 is the coefficient of x right here, but then we get minus r plus r1 is the coefficient. So that's why we equated right here. And I should have written down we are equating coefficients. Some commentary right here would have been nice, equating coefficients. And that's exactly what all of this is. In a similar fashion, let's just look at this one over here. 5a over 5, 52 over 2 would be equal to minus r plus r2. And then the product of the roots would be equal to this guy right here, right? So again, you guys can sort that out, but hopefully I should have written down equating coefficients as commentary here. Now, if we perform substitutions right here, first of all, multiply through by the constant. Like right here, I multiplied through by 2025, right? And notice that we can write down r sub 1 is equal to 5202 over 2025 times r. And that's what I did right here, folks. You see that? And so you see we got it all in terms of r. All we did right here is solve for r sub 1, which entails dividing by r, which means juxtaposing the r with 2025, right? Okay, so we get this statement. In a similar fashion, we get this statement, okay? Now, this part right here is just multiplying through by the constants. You end up with this, all right? Now, we have two different expressions that are equal to a, and that's a standard mathematical idea is you get the same thing, you get the same object with two different representations, okay? And so we can equate these two objects, and you end up with this statement right here. And again, not too hard to verify any of this. Again, you just equated them, and then you multiplied through by r. R is presumed not to be equal to 0, and it can't be in this context, right? There's no way it could be 0. So again, multiply through by r. You lose the minus signs also in the process, and you get this statement. Now, the cool thing about this is quadratic, right? So we have two roots, right? We can have no more than two roots. We have two or fewer roots, right? Two or fewer. I'll just write two roots, but it's two or fewer. Okay. Now, but notice that r equals to 1 trivially satisfies it, and so does r equals -1. So you see, it's okay. We don't have to do any kind of quadratic stuff here or whatever, you know. We can just observe that if r is 1, you get this sum here is equal to this sum over here. And it has to do with the fact that these guys are reciprocals up at the top, if you take a look at that, okay? So these are the two roots. These would be the two common roots. It says a common root up there, but there's two, okay? Now, so how do we figure out what a is? After all, we were supposed to find a, right? Well, notice here, this is kind of nice. If we write down g at 1, okay, equals to, I'll just use the top one, right? I am using the top one, 2025, right? If you put a 1 there. Plus x, right? That's 1's the identity element, plus 5202. Oh, y'all, sorry, my bad. I don't know what I'm thinking tonight. This is A, right? This is capital A, right? My bad. If you put a 1 right there for X, A is what's left, and we are looking for A, right? Okay, now this is equal to 0. Remember, G at 1 is a common root. That means G evaluated at 1 has to equal to 0. But watch what this certainly implies. This implies that A would be equal to negative, when you add this up, 7,000, what is that, and 27,257? 7257? Folks, and again, what I'm doing, I was just taking both of these constants. I'm just trying to, it's simple, but that will give you 7,000. And then 202 plus 25. Oh, that's 27 right there, right? 7227? Sorry. All right, so we get, this should be 72, 27, right? Again, I'm just checking the arithmetic here. Bring them to the other side, they become minus. And then 202 plus 25 would be, you get 7227 there, right? Okay. Now, in a similar fashion, I won't go through the tedium for you, but it's kind of in a symmetrical sort of fashion. G at -1 would imply G at -1 equals to 0, right? And if you go through the similar thing, you can see that you're going to get A is just equal to plus 7227, right? Okay. This is kind of sloppy here. A. Well, I did it there, didn't I? But this is also a candidate A, or it is an A, right? So these are our two A's right here. Let me get them circled. Now the instructions said to find an A. I could have put parenthetically plural S or something, parentheses S or something but I think it's okay just to leave the instructions that way. Okay. So these are the two A's that make that happen, and I hope you enjoyed that. I thought it was kind of some nice structure to it. It's kind of fun to go through this. And the fact that we're reciprocals really made this simplification work out like this. You wouldn't have been able to find these roots. In a lot of these problems, a better problem would be if you didn't have to actually find the root. There's probably a way to do it without actually finding the root, but we're supposed to find A. The way I did it determined what R was in a sort of a trivial fashion. So, but in any event, that completes it. And thanks for viewing.